Today we're going to focus on capital budgeting for the corporate owners, and we're going to look at the tools that Timberline provides to facilitate that. Timberline's estimating application is a spreadsheet-based application with a relational database behind it. The database that we're using for capital budgeting is RSMeans. RSMeans is a pricing service out there. It's also got 700 plus cost indexes for various cities across North America. And so we take advantage of all the power of that pricing of those cost indexes to provide that capital budgeting tool for the corporate owner. What I want to focus on is to talk a little bit about the Timberline application, how we do estimating, build it up from the bottom up, and then work our way into how the capital budgeting tool caps off all of the functionality of our estimating software. So I'm going to switch applications or switch estimates at this point. I'm going to start with a blank estimate at this point. And right now this would be like pulling up a blank Excel spreadsheet. What I want to do at this point is I want to start populating that spreadsheet with the items necessary for this capital budget. So there's a couple different ways we can do it. We have different ways of doing takeoff or putting items onto the spreadsheet, all represented by little icons. We've got quick takeoff, item takeoff, we've got assembly takeoff, and we've got model takeoff. And eventually we want to get to the model takeoff because model takeoff is the tool inside our estimating application that really facilitates the capital budgeting process. So to understand where we go when we get to model takeoff, I want to start at the quick takeoff level. When I click on the quick takeoff button, it pulls up a window that looks into my database. This is the database of items that are coming directly out of the RSMeans database. So for instance, this is what we call our group phase or our highest level in our database. If we want to go down to more specifics, we go down to one of the folders here, we double click on it, and it subdivides that into more specific categories. So if I wanted to go down into concrete ready mix, I could click on that, and we now get down to the actual items underneath that folder. To get those items out onto the spreadsheet, there's a couple different ways I can do it. First of all, I can go to one of the items and just double click them. Now as I do that, you'll see in the background it puts it out on the spreadsheet. If I want to, I can take that and drag and drop it. I can also highlight multiple items out here, hit my control key and select multiple items and drag those out there as well. Each one of those items populating my spreadsheet. I can also go to this list and say, I don't necessarily want to scroll through this list and I don't know the numbering structures for RSMeans, but I want to go out here and look at this by a certain description. So I can right click in this box and say sort that whole list by description. And I need a flagpole for my property, so I'm going to type in FLAG. It'll take me down to flagpole, and I need a 25-foot high flagpole. So as I do that, I drop it out onto my spreadsheet, and you'll see that it populates it out there. I'm going to close this window, and we're going to focus on the spreadsheet at this point. So right now I see a bunch of yellow items out on my spreadsheet. And the reason why those items are yellow is I've identified those as items necessary for this estimate. However, there's no dollars or quantities in those items. So as long as I see that color out there, it means that I have not completed my capital budget. So the first thing we want to do is we want to treat this just like Excel. So what I'm going to do is I'm going to go up into this first one, and I'm just going to type in 11 cubic yards. Now as soon as I press enter, you'll see that it turns that item white. You'll also notice that over in the material amount, it's got a number for material, and it's extended across and give me the total amount for that item. Now, if I don't want to manually figure out the cubic yards, if I want the system to prompt me for all the values that I need to enter, I can right-click on this cell, and it pulls up a little formula down here that asks me the length, the width, and the depth. So I can go inside of here and say it's 25 by 15 by 6 inches deep. And when I press enter, it calculates my cubic yards for me. Now, just like you would in Excel, if I wanted to right-click or highlight all the rest of them, right-click and fill down, they'll take values and fill down. We can also go down here and say that I've got 2 flagpoles out here, and it'll calculate exactly how much dollars for labor, material, equipment, and everything necessary to put that in there. All of the pricing coming from RSMeans, the standard pricing product. Now, just so you can understand what kind of pricing is in the background, what I'll do while I'm highlighted on this item, and it doesn't matter where I'm highlighted on this, I have a little magnifying glass. And that magnifying glass gives me kind of a picture or snapshot about what's happening in that item. So when I click on that button, it pulls up a little window. And just so you can understand where the prices are coming from, you'll notice down here that on the material I had 2 flagpoles, the same as the amount I put up here. and I priced it out in my database of $770 each and extended it across as $1,540. In this particular scenario, I've used a productivity that says, hey, every 9.4 man-hours I can put one of these in there. So based upon that, it's going to tell me exactly how many man-hours I need to put this in, extend it across, and so forth. So that's how we do the extension. So just for a comfort level, wanted to show you that so that you can see that we're not changing the way that you do estimating. All we're doing is giving you a tool to calculate those numbers quicker. Now, once we do take off items up here, if by chance you've got an equipment tab or you want to take off the complete footing of a building and so forth, there are more than one item that we would take off to do that. So instead of just taking off items one by one by one, what we did is we built construction methodology on top of the RSMeans item. Right now, if you took your RSMeans book and said, I want to use a budget, this number for budgets, you would have to take items one by one out of that book. What we did is we took all of those items and we grouped those in common tasks. We call those assemblies. So what I want to do is I want to take off an assembly. So I'm going to go into assembly takeoff, and let's say we'll take off a simple application such as a slab. So I'm going to go down here and say we're going to take off the slab. Down on the bottom of the screen, every potential item that could go into that slab comes in down on the bottom of the screen. The upper right-hand section of this thing gives me all the information I need to fill in about that. So, for instance, what's the slab area? What's the slab perimeter? Is there any thickness on this thing? Do we need to thicken the edge? These are completely intelligent questions up here. So, for instance, if I didn't want to thicken the edge, I would say no to that. At that point, it hides the questions underneath that. So it's intelligent enough to know that based upon the answer to one question, it may or may not need to ask me more questions. Once I've entered all the information on that assembly, and I hit the plus button to generate, it tells me down on the bottom that the total cost for that slab is $233,618.29. So instead of taking off just one item, it takes that common slab area and says, hey, I can use that dimension for several items underneath this, in this assembly or in the, based upon multiple items out of the RSMeans database. So when I say okay to that and go out into my spreadsheet, instead of just seeing those few items that I generated out there, I probably got about 2 pages of items generated out here based upon the assembly doing that. And of course, the database itself is pricing all of that information for me. So I've got all this information out here. You can see that out there. So items are the lowest level of our database. We take those items, we built the construction methodology on top of that to create what we call the assemblies, group those by tasks. But what models do is they take all those items and assemblies and they build them up into bigger packages yet. And those packages could be buildings or any type of superstructure or substructure or an above-grade parking structure, a below-grade, an office building, a residential tower, shopping center, whatever you might want to put together as a project that you would do, models takes advantage of that. So in order to show the functionality of models, what I want to do is I want to switch over into a blank estimate once again. So I'm going to go over here to this thing called above grade. We're going to do an above grade parking structure. Once again, we have a blank estimate up here. Now, instead of building this up from just pulling on items off items and assemblies, what I want to do is I'm going to go to models. So I'm going to click on this model takeoff. And what we're going to do is we're going to go down into this parking structure, the above grade parking structure. Now, what it's going to load up at this point is we call this an interview dialogue. And what the interview dialogue is a bunch of questions that we need to ask in order to get a budget. So, for instance, someone asks you to put together a capital budget, first thing you need to do is ask questions. Those questions are, how big is it? How many stories do you want? What type of skin type? If it's an office building, maybe what type of interior finishes do you want, and so forth. Well, that's what we've done in these models, is that we've given the same ability to answer those questions here. So we'll put a reference up here and say, this is my original budget. And what I want to do now is I'm going to go down into my questions here, down below, and I have what's called my conceptual control quantities. These conceptual control quantities are all the questions that I need to answer to get a capital budget. Now, we may refine this as we go along, and we have the facility to do that, but initially, these are typically the information that I need in order to get that budget. So it's going to ask me the parking structure square footage. You can see that it's got the parking structure footprint, how many decks do you need, different information like that. Now, in capital budgeting, we understand that oftentimes corporate owners have, a yearly time frame where they budget for all their capital projects. And so there may be a notice that goes around and says, all right, we need to have all the information of potential capital projects that need to go out. Well, one of the nice things that we can do is we can facilitate that with a function that integrates this with Excel. So, for instance, there's a little button up here above this. I said, would you like to get those values from Excel? So what I'm going to do is I'm going to click on that little button, and it's going to open up another question that says, where is the Excel spreadsheet that you've got? Well, what I'm going to do here is I'm going to pull up an Excel spreadsheet, and I've duplicated the capital budgeting interview, that particular model interview, out on Excel. And so I've got all the same questions out here that I would have in my interview. Now, to kind of look at the functionality and what you could use this for is, let's say that you have a capital budgeting process or period that you're going through, and you want to send out all the potential capital budgets that you need to budget for. Well, you may set up these Excel spreadsheets, distribute them around your company and say, do you have any capital budgets, fill in this information, and so forth. The nice thing about that is that all this information on this particular spreadsheet here, I've got once again, the same thing, the parking structure footprint, different things like that, what's your parking efficiency, square footage per stall, different things like that. When I go back over here to my estimate itself, and I say, where is that spreadsheet, I click on this little folder. And we're just going to go point it to that same spreadsheet that we just did. And we'll find that out here. It happens to be under estimates. And we're going to click on this above grade parking spreadsheet. It's going to take all of that data off of that spreadsheet, and it's going to drop it right into this capital budgeting questions for me. So now what I'm going to do is, now that I've got all the information in here, I'm going to say okay to that. And we're going to go ahead and we're going to generate a fairly detailed budget on this thing. And it's all going to be based upon RSMeans pricing. So once we're done with this, so what you'll see down here on the bottom is you'll see that it starts generating all the assemblies. So it takes those values that are up in the capital control, or the conceptual control quantities, and it drives them down through the values in the assemblies. So when we get done with this, you'll see that all of those assemblies are generated, and we're going to have a very comprehensive capital budget put together. Because oftentimes the problems we have with capital budgeting is that someone asks us how much a building is going to cost. We sit down and say, well, it's going to cost about $70 a square foot, or it's going to cost $80 a square foot, and someone then challenges us on where we got that number from. And, we basically look and say, well, we got some history on this thing. We did a building 5 years ago that's very similar, but we're going to put some escalation prices on there and all that information. Well, this gives us the facility to have current pricing based upon RSMeans right out of the box here. So we're just about done with this. And when I go out here and look at this, it says model generation complete. So we go out and look at the spreadsheet. What you'll see is you'll see a very detailed budget out here. Now, if anyone questions you on the pricing that you put inside of this thing, for instance, under the metals, how did you get $17,501 in labor? You have a tremendous amount of backing behind that. So if I look down underneath that, you can see that we've got all of the detail putting underneath that generates that information, the anchor bolts, even all that, down to that point if I'm going to go to masonry, all that information sitting underneath that, the reinforcing, the control joints, every bit of detail and backing on how you got those numbers is in there for you. Bottom line where we are, if I look at this, right now, based upon the numbers we got in our database, we're $6.9 million. Now, one of the things I said we had with the RSMeans database is 700 plus cost indexes. If I were to take and open up an RSMeans book and look at the price in the book, the price in that book would be a 30-city average. So it takes the 30 top metropolitan areas in the United States and North Dakota and Canada, and it takes those 30 and averages them. Those are the prices that you see in a book. You go to the back of the book and you index that price for the location that you're looking at. So this happens to be based upon the 30-city average, $6.9 million, $21.73 a square foot. So what I want to do at this point is I want to make sure that this is priced based upon a proper location. So I can go back onto my spreadsheet and I can say under the pricing, I want to reprice this from one of those cost indexes. So maybe I want to go to Oregon. So I'm going to go out to Oregon and I want to go right to Portland. So if I say okay to that, it's going to take all of those factors, just like you would in the back of the book, and it's going to apply it across all the items in this particular database. So you'll see the numbers change in the background. If I go back and look at the bottom line and where we are, you'll see that on the bottom line, based upon doing this in Portland, we're at almost $25 a square foot, $7.8 million. So we're quite considerably higher than the 30-city average out there. So based upon that, once we figure out a price or a capital budget on this thing, what we want to do is we want to have the ability to refine that. So someone else may come back to us and say, well, what if we did that above-grade parking structure, but instead of using precast concrete, what if we use structural steel? How would that affect our capital budget? So what we're going to do is we're going to take a copy of this estimate, and we're going to change some of the values in that conceptual control quantities to reflect that we want a structural steel number rather than precast. So we're going to go ahead and copy this estimate. All right, so we have just now made an exact duplicate of the previous estimate that we had. But now what we want to do is we want to fine-tune this. So we want to go out in this particular interview. And when we pull up the model interview, when we look at the interview based upon what's in this estimate so far, it has the identical interview information that we pulled in based upon our previous estimate. And so what we want to do is we want to go down inside the details of this particular model interview, and we want to change the options of having precast structural concrete to having structural steel. And then what we're going to do is we're going to take the information from that estimate, the regenerated estimate, and we're going to do a variance report that tells us exactly what the difference is in price. So as I go down here into the conceptual control quantities, you'll see the information that was driven from the Excel spreadsheet. But down below this, we've got information. For instance, under foundations, we've got information down under foundations. We've got the substructure. And really what we want to do is we want to move to the superstructure. And the superstructure, if I click on the superstructure options, it says option 1 has a structural precast column. That was the default, and that's what we used in our first generation. The second one, we want to change the second one. We want to actually change this to option number 3, which is structural steel. So I'm going to pick option number 3 inside of that. And based upon that, the questions down below it change as well. For instance, column-based spacing and so forth. We're going to leave the defaults the same way that they're there. And I'm just going to say okay to this. Now, once again, what it's going to do is it knows specifically that based upon that, when I go back out here and I generate this, it's going to go through all of those assemblies and items that were generated the first time, and it's going to change them based upon my new answers to these questions. So let's go back out to the estimate itself, and let's regenerate that out. So I'll hit the Generate button. And it's going to, once again, it's going to look through all of those assemblies. It's going to make the changes. It's going to find exactly if there was any changes to excavation and backfill, your footings, different things like that. So it's going back and analyzing that and making sure that that answer affects every item and assembly down below that. So once again, when we get done with that, we're going to come back with a very comprehensive estimate, not now based upon structural steel rather than the precast concrete. All right, the model generation is now complete, so we say okay to that. We go back out. We've got an estimate out there, and we can look at this particular estimate based upon this. Now, if I go back here and look at my totals on my bottom line, my totals come across, and they say that based upon that, we're at $8.4 million to go with the structural steel rather than the precast concrete. So what I want to do from a capital budgeting standpoint is if there's no compelling reason why we would go to structural steel over precast, I probably want to select the precast concrete as my capital budgeting items. So I can go back out here and say I've got those two, but if you wanted to look at exactly the differences, we do have, on the reports, we do have a thing called a variance report, and it allows me to take those two, take the structural steel and the precast, and let's go back and let's just take a preview of this and show you exactly what it looks like. So let's go ahead and do a preview of this of the actual variance report itself. And so if I look at this and I zoom in here a little bit, you can see that underneath my earthwork, there's a little bit of difference in here. But you notice under here in the structural metal framing, I've got a significant difference on the structural steel. There's about $2.7 million difference on that one. We've got about $897 on metal decking on this one. On the precast concrete, you'll notice that there's about a $3.6 million difference and so forth. So it's giving me a complete total down here, and of course the difference between those is about $611,000. So it's a nice little variance report that gives you a snapshot between the two of those things. Tells you the difference between them. Now once you just select which one that you want, we'll go ahead and close these down, that estimate down. Now what I want to do here is I'm going to go and open up that the precast concrete estimate. So let's open up the precast concrete one because that's the one we want to use because that's got the best pricing in there for me. So once we got that, the next question might be, how long do you think it's going to take to build this? Well, we have a complete integration with Microsoft Project and with Primavera. So one of the things we may want to do is go up to this interface button and send this out into a schedule. So if I can go out here and say, under the setup, I can say, send this out to either Microsoft Project or Primavera. And how do you want the tasks built? So what I want to do is I want to take every one of those assemblies that that model generated, and I want to create a task out of that over in Microsoft Project. So when I say OK to that, we're going to go ahead and generate that. And so it's going to generate all that information out into a schedule. So that when I pull up Microsoft Project down here, and we open up that schedule, it's going to have all the tasks built for me. Now, I don't have all of the network. You still have to put all your logic into this thing, but the majority of the time it takes to put a schedule together is just inputting the tasks. So there's my above-grade parking structure precast. I'm going to click on that particular project. It opens all that information up there. There are all of my activities there. Matter of fact, not only is it bringing over the duration information, but if I move this across, and I right-click on one of the headings here, I insert a column, I can pull in the cost directly from the estimate as well. So now not only do I have the durations, I've got the cost inside of there, and now all I've got to do is put your logic inside of that. So a tremendous tool for scheduling as well as just capital budgeting in here. So when you're putting a complete project scope together, you get everything you need in a package there. So in conclusion, you can see that Timberline's estimating application can handle any capital budgeting need in the marketplace. Whether you're doing small tenant improvement projects or whether you're doing multi-million dollar capital budgeting projects, Timberline's modeling application is a tool that will facilitate that, speed up time, gives you the detail and the backup that you need on the project information, and just to save you a tremendous amount of time and energy in putting your budgets together.